Good morning, Algebra. So we are actually going to be having two videos this week. And this very first video is going to be all about solving equations when we have variables on both sides of the equal sign. A little bit different than what we've done so far, but I think that it's really attainable for you all to get. So without further ado, let's get to the video.
All right, algebra. Today we're going to be talking about solving equations with variables on both sides. And by the end of this lesson, or by the end of this video, I'm hoping that you're able to solve equations with variables on both sides. So let's start off with our key vocabulary. We really have steps first. So steps for solving equations with variables on both sides. Simplify each side of the equation if possible first. That means you can do the distributive property. You can combine like terms. If fractions exist, multiply by the lowest common denominator and distribute. Okay, you could just multiply by that denominator and that will get rid of the fraction entirely. You then add or subtract to get variables on one side and numbers without variables on the other side of the equation. Multiply or divide to isolate the variable and then check your answer. So two pieces of vocabulary that we're going to have here. An equation is true for any value is going to be an identity. Identity is an equation that is true for any value always. And then an equation where there is no value to satisfy an equation, as in there's never going to be an answer, is actually just simply no solution. Let me rewrite that so it's a little bit easier to see. No solution. No solution. Okay, let's try solving some problems. So let's go through A and C because I know that we're going to want one with a fraction that's solved with us. So I have A, 8 plus 5y equals 7y minus 2. I look to see, is there anything that can be done automatically on either sides? Like, can I distribute or can I combine like terms? There are no like terms, so I'm going to draw my line to separate things. And then I'm going to try to start combining or moving my variables to be on the same side. So what I'm going to do is I'm going to try to eliminate this plus 5y, which means I need to do minus 5y on both sides. And I get 8 equals 2y minus 2. And I'm going to add by 2 on both sides. And that cancels these out. And I get 10 equals 2y. And then last, I just need to divide both sides by 2. And I get 5 equals y. And that was all that I had to do for this equation. Let's see, did I give myself more room? I didn't. That's unfortunate. So let's see if I can fit it in here and make everything really tiny. So I'm going to look here. 4/3 x plus 2 equals negative 7 plus 1/3 x. Well, there's no variables, there's no like terms, that I can combine, and there's no distributive property that I need to take care of. So what I'm going to do is I'm just going to start moving my variables, that way they're on the same side, and moving my numbers without variables, that way they're on the same side. So I'm going to subtract by 1/3 x first on both sides. And that eliminates these. And 4/3 minus 1/3 is actually just 3/3 or 1. So I'm left with just x. X plus 2 equals negative 7. Equals negative 7. So if I subtract by 2 on both sides, I get my final answer of x equals negative 9. And that'll be it. Let's try a couple more. Solving equations with grouping symbols. So again, let's try to do A and D, or A and C again. So first thing I need to do is, it looks like I need to distribute. I need to do that for both sides. So 5 times y is going to be 5y. And 5 times minus 4 is going to be minus 20 equals 7 times 2y is going to be 14y plus 7 times 1 is 7. And now it just goes back to how we're used to solving equations. So I'm going to subtract by 5y on both sides. And I'm going to have negative 20 equals 9y plus 7. Subtract both sides by 7. I get negative 27 equals 9y. Divide both sides by 9, and I'm going to be left with negative 3 equals y, and that is going to be my answer. Let's try another one. So I have 1/3 times 18, 1/3 times 12, and 6 times 2, and 6 times negative 7. So 1/3 times 18, or 18 divided by 3, is actually just going to be 6. And 1/3 times 12t, or 12t divided by 3, is going to be 4t. Equals 6 times 2t is 12t, and 6 times negative 7 is going to be negative 42. So again, I'm going to move all of my variables, that way they're on the same side. So I'm going to subtract by 4t on both sides. Cancels that out over there, and I'm left with 6 equals 8t minus 42. Now I'm going to add by 42 on both sides, and that eliminates that right there. Plus 42, and I'm left with 48 equals 8t. And since it's 8 times t, I need to divide by 8 to get rid of it. And I'm left with 6 equals t. Last slide. Finding special solutions in writing equations. So let's just go for A right now. So I'm going to have 5 times x and 5 times minus 7. So I have 2x plus 8 equals 5x minus 35 minus 3x. That just drops down. It looks like I have some like terms that I can combine. So I'm going to be left with 2x plus 8 equals 2x minus 35. Okay, so I'm going to try to get my variables to be on the same side, so I'm going to subtract by 2x on both sides. But that actually cancels both sides out, and I'm left with 8 equals negative 35. Well, that could never happen. So since 8 does not equal negative 35, that means that this is an example of no solution. I challenge you to try the other one on your own. And then last but certainly not least, this problem, 5 times the sum of a number. So 5 times the sum of a number and 3 is the same as 3 multiplied by 1 less than twice a number. So 2x twice a number, 1 less. What is the number right in the equation to solve? So now I just need to go ahead and distribute on both sides. So I have 5x plus 15 equals 6x minus 3. I'm going to subtract by 5x on both sides because I want to keep my x's positive. So that cancels over there, so I'm left with 15 equals x minus 3. Let's make that look a little bit better. So I'm going to add 3 to both sides, and I get 18 equals x as my final answer. And that is our video for today. So if you have any other questions, please feel free to make a comment in the comment section down below. You can message me on Schoology, but that is all that I have, and I hope that you have a great day.